All right, hello, welcome everyone. I know for those of us who are in the States, it's a good evening for many of us, but welcome. This is the latest GeoGebra webinar that we have prepared for you. And today the topic is on geometry using GeoGebra's latest resources. So my name is Monique. I am the lead curriculum and instructional designer at GeoGebra, and I was the lead on creating the latest resources that we released at the beginning of the school year. But now I'm excited to just introduce our guest. So today we have Karen Camp. She has been teaching mathematics for the last, I think, 15 years in Connecticut and Pennsylvania. She has also been doing professional development for math since 1998. And we're especially excited to have her because geometry is her favorite subject. And she has a huge passion for helping students understand math better with technology. And so she'll be able to give us a lot of insight on how to leverage technology in math teaching to help students better understand. Yeah, so while we continue on in this webinar, we would like you all to just feel free to use the chat. It is open. Feel free to introduce yourself, share what you teach, where you teach, even feel free to share your online handles. This is a GeoGebra community after all, so we'd love you all to participate. Yeah, and yeah, might as well get started.
Well, I'm so glad to be here, Monique. And like you've heard, geometry is my absolute favorite. And although there's other things that I've created on my own for geometry that's on the GeoGebra website, today's goal is to show you some of the GeoGebra team resources that are available that are ready-made for you to use in classrooms. So we've done an introduction. There are right now 92 resources of geometry and hundreds others in other topics. And I'm going to take you on a tour of some of the resources. Some of them introduce geometry concepts. Some of them use geometry tools. We're going to talk about two types of explorations that you might do to structure your lessons. And we're going to talk about practice activities, which will help students practice some geometry skills. If we have time, which I hope we do, we're going to do a live exploration where you're going to be our students in a GeoGebra classroom, and you can also use this in Google Classroom. And that way you can get the experience of being a student, and Monique's going to show you what the teacher dashboard looks like so you can see how that power can be brought to your classroom. We're so glad to be here, and let's carry on to the next slide, Monique. Now, we only have a half an hour, and I, as usual, over-prepared, so we're going to run through a lot of different things. Rather than trying to follow along on the website with me, save that to when we do our GeoGebra classroom activity at the end. And all of this is being recorded, so you can find all these activities after you participate tonight. You can see them on the recording. Okay, so what Monique has up there on the screen is the GeoGebra homepage. And on that homepage, you get to the resources in a few different ways. I usually go to the left side where it says resources, but you can also click on the math resources button right smack in the middle of the page, or up at the URL bar, you can just type in geogebra.org/math. And would you go ahead and go ahead, Monique, and go to that. And when you get to the math resources, you've got 6 main topics, and tonight's job is to go through some of the geometry resources. By the way, what you're going to see when you open up the geometry resources is you're going to see that they're divided into upper elementary grades 4 and 5 and middle school grades 6 to 8. Now, honestly, I started as a high school teacher. I have found so many items here that are useful for high school math, and there's also a lot of overlap between upper elementary and middle grades. And so I pretty much ignore the grade levels and I pick items that would be useful for the students I'm working with. And every state is different, and so use what works for you and don't be worried that, oh, I'm teaching high school geometry. Should I not look at the grades 4 to 5 items? I just ignore that and see if it's worthwhile for my class. Okay, I'm going to share my screen. So let's actually, yeah, I'm going to share my screen. And what I want to do is we're going to take a tour of the resources, and I've got 8 activities that I've lined up to do here. So it's pretty ambitious. So we'll see if I can get through them all. But before we actually dive into them, what I want to show you is that from the menu screen that Monique was just showing, and also from within the activities, you have ways to tell what kind of activity you are. On this left side of this slide here, you can see that each activity is designated either an exploration activity or a practice, and they also give the grade level. And when you're in activities, it says on the right side, am I in an exploration or a practice? So those two formats will differ, and you can use them for different purposes in your classroom. And so now what I'm going to do is we're going to go to our first activity, which is identifying angles around us. And this is really pretty pretty small, not small, but it's pretty introductory. And that's why I wanted to show it to you, because you can use these activities as a way to introduce some geometry terms and objects. This exploration has an interactive magnifier. And before I start moving my magnifying glass, we want students to think about, do you see any angles in the picture? And as we move our magnifying glass, we're going to see, oh, look, there's an acute angle. There's another acute angle, and all the way over here is an obtuse angle. And you can keep moving it around, and it's very basic, but I think it's kind of lovely, has a straight angle as well, and it lets students find where these angles might be in a picture, and it can give you another picture, and you can do the same thing. And one of the things that I liked to think about is I can imagine my students, or students younger than my students, saying, oh, but there's not all the angles. They missed an angle. Like here, they've got this obtuse angle and that obtuse angle and a straight angle, but I see other angles here. So I think it really is an opportunity for discussion. What angles did the magnifying glass miss? And in every exploration activity, there's going to be a section called putting it all together. And there's going to be questions. And some of these are going to reinforce whatever was in the activity, and some of them are going to go beyond the activity. But there's an opportunity for students to build on what they just experienced. Our next
Karen,
introduction.
before we move on, do you mind stretching your window screen to the right?
Oh, you bet.
And
Sorry.
then, yeah.
Sorry, I thought it was covered, but it is not. I had the chat there before.
And then could you also zoom in on the web page a little bit?
Sure.
You can like Command plus or something.
You bet.
Yeah, that way we can see it a little better.
How's that?
Yeah, that's better. Thank you.
Okay, fabulous. So the next one I wanted to do is also an introduction, right? It's where we're trying to help students build their knowledge of basic geometry ideas. And so this one is types of triangles. And what's different about this one versus that magnifying glass one is it starts without a triangle at all, and it says drag to start. And dragging and observing is sort of a key action that we want students to do when they are interacting with dynamic environments. So I love when it gives us a drag to start, and our job is to drag, or the student's job actually, is to drag these points around and create a triangle. And once we've created a triangle that we're happy with, the best thing about the prompt to drag is that my triangle will be different from your triangle, be different from Monique's triangle, from Brad's triangle. Everybody's triangle is going to be different. Then if you click on a side, the 3 sides of the triangle are not congruent, and it tells me it's a scalene triangle. Maybe I want to try and make it not scalene. Can I do it? Let's see. If I have rearranged it to get it to be isosceles, now it's going to pop up with an isosceles message, giving me immediate feedback about whether my attempt at an isosceles triangle will work. If you click on an angle, it will talk to you about the type of angles you have. And this triangle is acute because all three angle measures are less than 90. If I change the angle, the triangle, now it'll tell me it's a right triangle. If I change it again and click on the angle, it's going to be obtuse. So this kind of dynamic thing where I get to interact and act on this dynamic environment and see the consequence, that allows students to really get a nice bit of learning going on. So these kinds of introductory activities introduce geometric terms and figures, and these are not the only ones out of all those 92 resources. So if you need to do something to get kids going on some basic ideas, it's a really good place to go. And what I also love is that these putting it all together questions are really getting at some things that high school students have trouble thinking about. Can a triangle be scalene and isosceles? Can it be, what makes a right triangle? Can a triangle be isosceles and right? When I get to my high school students, I definitely want to ask them, can we have two right angles, or can we have an isosceles, an obtuse angle and a right angle? So there's all sorts of things that you can use this as a jumping off point for. And I would encourage you to add other questions in your classroom when you're using this activity. You can go beyond what you have there. The next activity is another introduction, and this is an introduction to a particular tool. So protractors are not the only tools in the resources. I know there are rulers and number lines. Monique, are there any compasses? I can't remember now.
We have not a an explicit compass. We have another activity where you actually draw an angle or create an angle that has a certain angle measure.
Mm-hmm.
Um,
Okay, well, I couldn't remember. I've looked through so many activities this week preparing for the webinar. I couldn't remember if there was a compass or not. But what I loved about this one is, first of all, you can move your protractor, okay, and move your protractor to where you want it to be, and then read off what you think your angle is. So I'm reading my angle, and this one, it looks like it's 135. So I'm going to type 135. And anytime you are in a practice activity, you get opportunities, 3 tries to get your questions right. And we got it right the first time, so I'm going to do a new problem. And what I like about this is that there, as we all know, there's more than one way to line this up. I can line it up this way and open counterclockwise, but I can also line it up, whoops, let's get it going. Sorry. I can line it up this way and we can measure from the other side. And students will, as we know, move protractors all which way around. I'm going to pretend that I'm making a mistake as a student, 164 degrees. And it tells me try again. It gives me a hint. It says, be sure to begin measuring from 0. So I have to read the other scale. So it looks like it's going to be 16 degrees. And now I've gotten it correct. So I love that this activity gives me different ways I can lay down my protractor, and it gives me more than one opportunity to try. And it's very nice. It gives me very supportive feedback. It doesn't just say you're wrong and move on. If you were to get it wrong, I think all 3 times you get a full solution, which is really, really nice. The next activity is an exploration activity, and it's the sum of the interior angles of a polygon. You know, Monique, is my captions showing up at the bottom of the screen?
it is.
Okay, I don't know how to turn that off, and I would love to turn that off because I think they're in the way. Let me stop sharing and turn them off. There we go. Okay, and now I'll share again. Okay, sorry about
I
that.
believe you can just drag the captions out of the way as well.
Oh, okay, that's good to know. Okay, so this activity is the sum of the interior angles of a polygon. When you're choosing any tech activity to use with your students, one consideration is what are the prerequisite skills? And I'm not sure you won't be surprised that the prerequisite skill for this activity is to know about the number of degrees of the angles of a triangle. And that is something that I would have done with my students first. And the other thing, again, that this activity I love is it says drag to explore. So it encourages, invites the student to rearrange this picture. It's not going to let us move everything every which way. It has some constraints because of what's to come. But it means that if you tell your students drag first, then we aren't all looking at the exact same figure. So we drag that to change the shape and then click to draw triangles. And we're going to get this wonderful animation. Let's check it out. It's going to draw triangles and shade all the angles. And if we look what they've done, this pink angle, this light purple angle, and this brown angle are here, making 180 degrees, because that's my top left triangle. And this little green angle and this magenta angle and this blue angle make another 180 degrees, which makes 360. And then we have to remember, this is a dynamic environment. Let's drag it some more. Watch how the pictures at the bottom of the screen are changing as my quadrilateral is changing. Okay, so you can drag both times. Underneath this, there are some targeted questions to help students think about this. It reminds them of the sum of the measures of the three angles of a triangle. It actually asks them to extend and apply what would happen if we use 10-sided or 100-sided. All I've done so far is a quadrilateral. You can now, I'm going to go and change this to a 5-sided figure. And again, I can rearrange it. Again, I can draw my triangles. And now I get 3 triangles, 3 sets of 180. And you know what's coming? 6, draw the triangles. And we're going to get 4 sets of 180. Now that's as many sides as we can go in this activity. The prediction questions are going way beyond that. And what these prediction questions don't have right now, or the set of questions, these questions are not asking students to come up with a formula or summarizing it. So me as the teacher, I think that summarizing the lesson that I wanted students to get from this is really, really important to help make the math stick and have that learning be deeper and more durable. So I would, if I'm using this in my classroom, would make sure that I summarize with the class, and often those summaries are going to be directed by the students. It's not necessarily going to be teacher directed, but those summaries and consolidation times lets me clarify misconceptions and just make sure that what I thought I taught the kids actually heard and wrote down somewhere. The next activity, also with polygons, is going to be the sum of the exterior angles. And again, drag to change the shape. And we've got 3 sides, and we're going to slide to animate. And I bet you can guess what those 3 angles, because we're all math teachers probably, they're going to make a whole circle, 360 degrees. And again, we can change this as we go, and the 360 changes. I'm going to reset the animation before I change the number of sides. And I love this because we've got 4 sides, also makes 360, and reset, and 5 sides makes 360, and you can really go to town. You can change the number of sides after that animation is there. So we can go to 6 sides, 7 sides, 8 sides without having to reset. But I think it's really fun to go and reset. And part of what we're doing here is we're making sure that students are engaging in the activity, not just watching a video, not just playing around and watching things move. We want to make sure that the questions we ask and the discussions we have in the classroom really pushes them to think about this action that they've taken, reflect on it. Okay, and so the putting it all together questions, again, are fabulous. They're really nice. What shape is formed? How many degrees in a circle? What is the sum of the measures? Will it always be the same? How do you know? This can be a jumping off point for proving it. And it can also really give you an opportunity to leverage this power of dynamic figures. I can change this picture, and so my picture won't be the same as the student sitting next to me. Now, those last two on polygons, I call type 1 explorations. And what do I mean by type 1 explorations? Both the polygon interior sum and the polygon exterior sum funneled our students into the right answer. Okay, it got them along similar pathways to come to similar conclusions. And this, I call it type 1, that comes from an article by McGraw and Grant in the 2005 NCTM yearbook. It was a special yearbook focused on technology, and they were talking about two different lesson structures. And this is type 1, where students work along similar pathways to try to come to a similar conclusion. And it's a really important and useful structure because it's the bread and butter of a lot of dynamic lessons. We use the dynamic lessons to help the students learn some math that we want them to learn. It's not especially open-ended because if I do the activity or Katie does the activity or John does the activity, if we all do it, we're going to get to the same place. The type 2 lesson structure that McGraw and Grant talk about is a situation where students can decide what they want to investigate. It's much more open-ended, and so it can be very rich and fruitful, but it can also make teachers uncomfortable because they don't know where the students are going to get to. And honestly, some students are kind of uncomfortable if they don't have the skills to sort of pursue an open-ended investigation. But let me show you another resource that helps them to try something out. And this resource is in the solids, the geometric solids, and it is making cross sections of a prism. And the first part of it I would call a type 1 exploration, because if I want to be parallel to the bases, if I want to move this plane, everybody's going to move the plane and see what that shape is going to be. We can talk about that shape. That shape is going to be a congruent shape to the top and bottom base. If we want to be parallel to the lateral faces, we're also going to be congruent, but we're going to go this way, and then it's going to go the other way. So that part is still sort of a type 1 lesson. I do want to show you that this is a 3D activity. So I can click here and we can rotate this and look at it from a whole bunch of different vantage points. And if I'm teaching high school geometry, I also will definitely talk about the similar activity, which instead of making cross sections of a prism, there's cross sections of a pyramid, where instead of getting congruent shapes, I'm going to get similar shapes. So I'm going to pull that out and do that in the similarity unit in my high school geometry class. But here's the payoff now. Here's a type 2 lesson. If I want to take any plane and explore and not be parallel, look what it gives me. It gives me a plane, okay, and I can move these points and I can create all sorts of shapes. Can I make a quadrilateral? There's a quadrilateral. Let's look around. What did I do? It's not going through, it's only going through 2 vertices, but it is indeed, it might be a rhombus, might be a parallelogram, I'm not sure. I can undo that. I can make, whoops, I can make a pentagon. So there's all sorts of fun that you can have students do here. And this is very much a type 2 exploration. It's totally different than anything else. The questions that they ask are, what are the possible shapes? What did you notice? But I really think that even though a type 2 exploration might feel very uncomfortable because you don't really have a goal especially in your mind and students might get different answers, I think it's really fun to try it because it opens up a really rich scenic route for the math. Okay, I'm looking at the time and I want to show you 2 more things, so let's go to it. My next one is a Pythagorean animation. And my students have gotten very, very good about going, going, going. They totally know that they should drag, they should change things. And so what I want to do, if I'm going to put this up on and use this in my classroom, first I'm going to have my students have hands off the computers, and I'm going to have this displayed, and I'm going to ask them to, let's look at this, let's notice and wonder what's going on here. And what I want my students to notice is that I've got a right triangle with squares built on each side. And then I'll let them go ahead and drag. And you can see that the larger of the two triangles gets broken up into 4 different areas. And we slide to animate. And what's going to happen is that the areas of those 2 small squares will exactly equal the areas of the large square. And you can even move this and drag it after they've filled that space. Okay, and so the next thing I want to share, and there were questions that went with that, with the Pythagorean theorem, but we're running short on time. My last activity is going to end up being our GeoGebra classroom activity. And rigid transformations was a whole group of activities. And I called this the transformation goldmine because it has so many activities here. It has properties of the different transformations. Can you create them? Can you look at transformations in a coordinate environment? This section here is a whole bunch of challenges. Can you tell me what transformation happened? Or can you put together a series of transformation? And we're going to do one of these together in a few minutes, but this is just a gold mine. If you're doing anything with transformations, there's some wonderful things. Monique, can you go back to the slideshow if I stop sharing? I just want to quickly talk about some things to keep in mind, and then we'll take a look at that last activity.
Sure thing.
So I want to get to the things to keep in mind. Here we go. So just some things, and I've mentioned some of these already. Decide whether you're going to do an explore resource or a practice resource. The explore ones has the follow-up questions, and the practice resource gives students opportunities to try 3 times with some hints and solutions if they get it wrong. I work a lot on the action consequence reflection cycle, and I've sort of alluded to this along the way. I want students to perform a mathematical action and observe some consequence in the dynamic environment. And I've highlighted the word reflection because the reflection piece is the key part to make the math stick. How do you get students to reflect? Get them to record their observations, have them, you ask and have them answer targeted questions on the material, and summarize and consolidate the learning. One other thing we talked about along the way was a type 1 versus a type 2 lesson structure. Are you trying to funnel kids to one solution, or you're trying to really open it up and let them explore? And the last thing to keep in mind is when to use these activities in your teaching. Sometimes I've used these as warm-ups or pre-assessments before a unit. I've used them for absent students or self-checks. I've used them for a whole lab activity in a classroom, although they're really kind of bite-sized. I have some other lab activities in my own GeoGebra materials that are a little bit more fleshed out. But basically, the other thing to use these for is to practice for tests or consolidate your unit. And let's now, Monique, go ahead and take a look at that rotation activity in the GeoGebra classroom.
All right. So we're going to try an activity ourselves, and we're going to use GeoGebra Classroom, which is basically a way to distribute these resources to students. Say I think the way that Karen has been showing the resources has been, like let's say you project it onto the screen or something like that, and you want to have a class-wide discussion. But what if you want the students to work independently for a little bit of time? So actually, in order to participate here, you do not need a GeoGebra account. You need a GeoGebra account to create a GeoGebra classroom environment. That is something that if you would like more details about, you can go to the previous webinar recordings. They're on our YouTube channel. But I have created this link already. And so please, if you can just go to the link in the chat, or you can go to geogebra.org/classroom and type in the code. But it's always good to see what the students are seeing. So when you're using GeoGebra Classroom with this rotation activity, So join the link. If you're not logged into a Geogebra account, that's okay. You can just type in your name. Right.
And I chose this activity because what it's going to have you do is identify the rotation that's happening. And you have to fill in certain parameters of rotation. Which way did it rotate, clockwise or counterclockwise? What was the center of rotation? And what was the degree of the rotation? But the nice thing when you get to the activity, there's a rotate button at the bottom of the screen so you can see what the rotation was.
Okay.
When I
We
teach
have enough people
rotations,
who.
oh, sorry, Monique, yeah, people are in it. And when I teach rotations, especially once we get to trigonometry and, upper level high school math, there's more than one way to describe a rotation. And I found that this activity clued me in pretty quickly that it wanted one answer. But that for me gave me an opportunity to talk about what are the other ways we could describe this rotation. So it becomes a good discussion jumping off point. And when you're trying it, see what happens if you put in a wrong answer. And it gives you some hints and things. And what Monique is showing is the dashboard that you can see as a teacher.
So something I can do is I can actually pause this classroom. I can say, all right, everyone, look at my screen now. And I'll hit resume so I don't forget. So you all can explore more later. But I can also look in each person's like snapshot. So for example, I can open up Karen's and I can see where she's at. I can see the type of problem that she's working on. So maybe she's struggling a little bit, and I can tell, and I can just without coming all the way up to her and looking over her shoulder, I can see, oh, okay, this is the type of problem that she's working on. Maybe that's why it's a little bit more challenging, and maybe she's just thinking about it a little bit harder. I can also see how many that she got correct.
Okay. I hope you got a little taste of everything that we had to show you tonight.
Yep.
Oh, this slide, I'm not going to take the time to show you, but there's also community resources, not just the ones that we've been showing you that are coming from the Geogebra team. These are made by everyday people, made by me, made by other people. And any activity that you search for on the Geogebra website, whether it's made by the Geogebra team or anybody else, try it yourself, decide if it makes sense for your students, decide if they have prerequisite skills or different questions that you want to ask, because you know your students better, and that's going to make sure that it's going to be successful in your classroom.
We don't have much time for questions. You can type them in the chat and we might have some time after we stop the recording to answer them. The next webinar that we have will be in next month in February, and it will be covering the topic of probability and statistics. So we're going to look at the resources in that subject area and talk about some of the specifics in some of the resources there. If you'd like a copy of the slides, here's a QR code, and you can register for a copy. Again, this will be recorded, and for those who have signed up for the webinar, there will be an email with the link to the recording shortly after in the coming days. And then this is some of Karen's information. Did you have any comments you wanted to make on this?
Well, I just wanted to say I've been writing blog posts. Some are just some old calendars from NCTM for problem solving, but the Reflections and Tangents blog has a new one up this past week. My GeoGebra resources are at geogebra.org/u/kdcamp. And if you're interested in more about the action consequence reflection cycle, I have a whole book of action consequence activities that really build on those ideas. And you can find me on the different online communities, Twitter, Blue Sky, Mastodon, and in the GeoGebra Facebook group. And my email is karen.camp@gmail.com. Thank you so much for spending time with us tonight.
Yep. Again, thank you so much. We have a community email if you had any more questions after the fact, if you had feedback or suggestions about these resources. And of course, you can follow us at GeoGebra on all the socials. Thank you so much for attending and participating. And thank you so much, Karen, for joining us today.
It was my pleasure. Thanks for having me.